Chapter 14. Salt in Medicine. Ancient Antiseptic Uses. Before antibiotics, there was salt. Before sterilization, there was salt. Before anyone even knew what germs were, there was salt. Walk into an Egyptian temple, 3000 BC. A priest-physician tends to a wounded soldier, deep gash across the arm, bleeding, already infected. What does he reach for? Salt. He packs the wound with it, washes it with salt water, covers it with bandages soaked in brine. The patient screams. The salt burns like fire. But days later, when the bandages come off, something remarkable has happened. The wound is clean. The infection has stopped spreading. Healing has begun. This scene repeated everywhere. Egypt, Greece, Rome, China, India. Different languages, different gods, different medical philosophies, but the same treatment. Salt for wounds. The ancient Greeks understood this power. Hippocrates, the father of medicine himself, wrote extensively about salt's healing properties. Salt water for cleaning ulcers, salt baths for skin diseases, salt solutions for digestive problems. His reasoning was wrong by modern standards. He believed salt balanced the bodily humors, that it had some mystical drying and heating property. But his observations were correct. Salt worked. Roman army surgeons became experts in salt treatment. They had to be. Their patients were soldiers, sword cuts, arrow wounds, infected blisters from long marches. They discovered that different concentrations had different effects. Weak brine for washing, strong brine for preserving amputated limbs, crystalline salt for packing deep wounds. They even developed a ranking system. First-class wounds received pure salt. Second-class wounds got salt water. Third-class wounds, if the soldier was lucky, got whatever was available. In medieval Islamic hospitals, salt became part of a sophisticated toolkit. Al-Razi, the great Persian physician, documented using salt to treat eye infections. He dissolved pure salt in rose water, applied it drop by drop to inflamed eyes. The results were remarkable. Infections cleared, vision improved. He didn't know about bacteria, didn't know that salt's osmotic properties literally pulled water out of bacterial cells, causing them to collapse and die. He just knew it worked. The same principle was applied everywhere. Ancient Chinese physicians prescribed salt water rinses for mouth sores. Indian Ayurvedic practitioners used salt scrubs for skin infections. European barber surgeons packed tooth extraction sites with salt. All of them, independently, discovered the same truth. Salt kills what shouldn't be there. But here's the fascinating part. The dosage mattered. Too little salt, and it did nothing. The concentration wasn't high enough to affect bacteria. Too much salt, and it damaged healthy tissue. The ancient physicians, through trial and error, found the sweet spot, usually somewhere between 3 and 10% concentration. Pure empiricism, no microscopes, no laboratory tests, just observation and adjustment. And it saved countless lives. When the Black Plague swept through Europe, some physicians recommended saltwater gargles. Did it help against plague? No, plague is systemic. But for the secondary infections, the pneumonia, the skin lesions, the salt probably did help. It wasn't a cure, but it was something. In an age of helplessness, that mattered. The antiseptic use of salt continued right up until the 20th century. World War I field hospitals used salt solutions when they ran out of iodine. World War II medics carried salt packets for emergency wound treatment. Even today, in remote areas, without modern medicine, salt water remains the go-to treatment because the chemistry hasn't changed. Bacteria still can't survive in high salt environments. Salt still draws out infection, still promotes drainage, still creates an environment where healing can begin. Ancient physicians didn't understand the mechanism, but they didn't need to. They understood the result. And in medicine, sometimes that's all that matters. Salt, the first antiseptic,
the original antibiotic. White crystals, holding back the invisible tide of decay and death.
2. Saline solutions in modern IV therapy.
Now let's jump forward to the modern emergency room. A patient crashes through the doors, severe dehydration, maybe cholera, maybe heat stroke, maybe massive blood loss. They're dying. Minutes matter. What's the first thing the doctor orders? IV saline. That clear bag hanging on the pole, that tube running into the patient's vein, that liquid bringing them back from the edge of death, it's salt water, 0.9% sodium chloride, normal saline, the most common medical intervention in the world. But this isn't just salt dissolved in water. This is precision, chemistry calibrated to match the exact salinity of human blood. Let's understand why this matters. Your blood is essentially seawater, a very specific concentration of seawater, about 0.9% salt. Too little salt and your cells swell and burst, a condition called hyponatremia. Too much salt and your cells shrivel and die, hypernatremia. The balance is exquisitely delicate, and normal saline maintains that balance. When a patient is dehydrated, they've lost both water and salt. Their blood becomes thick, sluggish. The heart struggles to pump it. Giving pure water would be disastrous. It would dilute the blood's salt concentration. Cells would swell. But giving normal saline, that works perfectly. It expands blood volume without disrupting the salt balance. The patient's blood pressure rises, oxygen starts reaching their tissues again, kidneys begin functioning, brain clears. It's almost miraculous to watch. Someone on the verge of death restored to consciousness within minutes, all because of salt water. The development of IV therapy is one of medicine's great triumphs. In 1831, during a cholera outbreak in Scotland, a physician named Thomas Latta tried something desperate. He took salt water, warmed it, and injected it directly into a dying patient's veins. The patient recovered.
It was revolutionary, heretical. Some doctors called it madness, but it worked. And within decades, saline IV therapy became standard practice. Today, hospitals use millions of bags of saline every year. It's the foundation of nearly every emergency intervention. Trauma? Start a saline drip. Surgery? Maintain volume with saline. Medication delivery? Dissolve it in saline. The beauty of saline is its simplicity. Water, salt, nothing else. No complex molecules, no synthetic chemicals, just the same ingredients that make up seawater, mixed in the same proportions that make up our blood. It's a reminder of our origin. We came from the ocean. We carry the ocean within us, and when our internal ocean runs dry, we refill it with salt water. But saline does more than just replace volume. It's the universal solvent for medication. Nearly any drug can be dissolved in saline and delivered intravenously. Antibiotics, painkillers, chemotherapy, vitamins, all of them traveled into the body on a vehicle of salt water. Saline is also the base for more sophisticated IV solutions, lactated ringers, plasmolite. These are balanced salt solutions that include potassium and calcium, but they all start with the same foundation, sodium chloride, salt. There's even a dark poetry to it. In ancient times, salt preserved the dead, prevented decay, held back corruption. In modern medicine, salt preserves the living, prevents shock, holds back death. The chemistry is the same. The purpose has flipped. And every day in hospitals around the world, millions of people are saved by the same mineral that once preserved Egyptian mummies. Salt, in solution, in service, in salvation. The ocean we carry within us, replenished by human ingenuity and chemical precision.
3. Oral Rehydration Therapy. Bangladesh, 1971. A refugee camp. Thousands of people fleeing war, living in desperate conditions. Then cholera strikes. Cholera is a death sentence in these circumstances. The bacteria cause massive diarrhea. Patients lose liters of fluid within hours. Dehydration, shock,
death. Even with IV therapy, the overwhelmed medical staff can't keep up. There aren't enough needles, enough bags of saline, enough hands to insert IV lines. People are dying faster than they can be treated. Then a doctor tries something radical, something so simple it seemed almost insulting. He mixes sugar and salt in clean water, gives it to patients to drink, and they start recovering. This moment marks the birth of Oral Rehydration Therapy, ORT, what the medical journal Lancet would later call potentially the most important medical advance of the 20th century. More important than antibiotics? Than vaccines? In terms of lives saved, possibly yes. Here's why it works. Cholera destroys the intestine's ability to absorb plain water. Give a cholera patient pure water and it passes right through. Doesn't help. But add sugar and salt in the right ratio and something changes. The sugar provides glucose. Glucose activates transport proteins in the intestinal wall. These proteins pull the glucose across, and they drag sodium with them. And where sodium goes, water follows. It's called co-transport, a biological quirk that becomes a life-saving tool. The formula is simple. 6 teaspoons of sugar, half a teaspoon of salt, 1 liter of clean water. That's it. No prescription needed, no medical degree required. Parents can mix it at home. And it works against cholera, rotavirus, dysentery, any condition that causes dehydration through diarrhea. The impact has been staggering. Before ORT, childhood diarrhea killed about 5 million kids a year. Now, less than 500,000. That's not a typo. A 90% reduction in mortality. One simple intervention: sugar, salt, and water. UNICEF and WHO have distributed billions of ORT packets, small foil sachets, available in every rural clinic from Africa to Asia. Mothers are taught to mix it at the first sign of diarrhea, before the child becomes critically ill, before dehydration sets in. Prevention instead of crisis management. And the cost? A few cents per packet. Compare that to IV therapy, which requires trained staff, sterile equipment, and expensive fluids. ORT democratized life-saving medicine, made it accessible to the poorest communities on Earth. But here's what's often forgotten. The salt is crucial. Not just any salt, the right amount of salt. Too little and the solution doesn't work. The sodium gradient isn't strong enough. Too much and it makes the diarrhea worse, draws more water into the intestines. The WHO formula is calibrated precisely. 2.6 grams of sodium chloride per liter, about half a teaspoon. That precision matters because in desperate situations, people sometimes get it wrong. Too little sugar, too much salt, the wrong water source. That's why pre-mixed packets are so important. They remove the guesswork. But the underlying principle remains simple enough for anyone to understand. Your body is losing salt and water. Replace both in the right proportions. Let the sugar unlock the door. Let the salt bring the water through. Your intestines remember how to absorb. You just need to give them the right key. ORT is a triumph of understanding. Not just chemistry, but physiology. It's a reminder that sometimes the most powerful medicine isn't complex. Sometimes it's elementary. Sometimes it's just salt and sugar in water. The same ingredients humans have known for thousands of years, rearranged with precision, delivered with care, turning the ocean we carry within into the solution that saves us.
4. Salt's role in blood chemistry. Let's go deeper now, into the bloodstream, into the microscopic world where salt becomes electricity. Your blood is more than just a delivery system. It's a chemical computer, a flowing network of signals and responses, and salt is the language it speaks. Every heartbeat, every nerve impulse, every muscle contraction, all of them depend on sodium and chloride ions dancing through your system. Here's how it works. Your heart is a muscle, but it's not like your bicep. It doesn't wait for you to decide to beat. It generates its own electricity, a wave of charge that sweeps through the heart tissue, causing it to contract in perfect rhythm.
That electrical wave is created by sodium ions flooding into heart cells, then potassium ions flooding out. This ion exchange happens in milliseconds, over and over, 70 times a minute, 100,000 times a day. Without sodium, the charge doesn't build, the wave doesn't propagate, your heart stops. The same principle applies to your nervous system. Every thought you have, every sensation you feel, every command from your brain to your muscles, all of it travels as electrical signals along nerve fibers. Those signals are sodium-driven. When a nerve fires, sodium channels in the cell membrane snap open. Sodium rushes in. The inside of the cell becomes positive. This charge races down the nerve fiber at hundreds of miles per hour. Then sodium-potassium pumps work to reset the system, push the sodium back out, pull the potassium back in, ready for the next signal. This happens trillions of times per second across your entire nervous system. Your ability to read these words right now depends on sodium flowing into the nerve cells of your eyes and brain. Your muscles, too, rely on the same mechanism. When you decide to move your arm, your brain sends a signal. That signal is a cascade of sodium entering and leaving nerve cells. When it reaches your muscle, calcium gets involved. But the initial trigger? Always sodium. No salt, no signals, no movement.
Now let's talk about blood pressure. Your kidneys are exquisitely sensitive to sodium levels. They act as your body's salt regulators. Too much sodium in the blood, and the kidneys try to excrete it. But sodium drags water with it. So more sodium means more blood volume. More blood volume means higher blood pressure. This is why doctors tell heart patients to reduce salt intake. Lower sodium, lower volume, lower pressure. But here's the paradox. Too little sodium is just as dangerous, maybe more so. Drop your blood sodium below 135 milliequivalents per liter and you develop hyponatremia. Early symptoms? Confusion, headache, nausea. Severe symptoms? Seizures, coma, brain swelling, death. Marathon runners have died from hyponatremia. They drink too much pure water during the race, dilute their blood sodium, their brains swell inside their skulls. The balance is everything. And your body fights desperately to maintain that balance. When you sweat, you lose salt, so your kidneys conserve it, hold on to every molecule. When you eat a salty meal, you get thirsty. Your body demands water to dilute the sodium. When you're dehydrated, you crave salt. Your body tries to pull in sodium to retain what little water you have left. It's a continuous feedback loop, monitored by sensors in your kidneys, brain, and heart. All of it in service of maintaining that 0.9% salinity, the same concentration as the primordial ocean our ancestors evolved in. We left the sea, but we brought the sea with us. Every cell in your body floats in a salty soup. Every cell depends on the precise movement of salt ions to function. Your kidneys filter 180 liters of blood per day. They reabsorb 99% of the sodium, return it to your bloodstream. That 1% they let go, that's what you pee out. That's the salt you have to replace through food. About 3.4 grams per day for most people, less than a teaspoon. Such a small amount, but absolutely critical. Because salt isn't just in your blood. It's in your tears, your sweat, your saliva. It's in the fluids surrounding your brain and spinal cord. It's in the gel inside your eyeballs. It's everywhere water is, because water and salt are inseparable in biology. When we talk about blood chemistry, we're really talking about salt chemistry, the elaborate dance of sodium and chloride and potassium, the electric ballet that keeps you conscious, breathing, thinking, moving. All of it choreographed by white crystals. You probably scattered them on your eggs this morning. Salt, not just a seasoning, not just a preservative, the fundamental currency of life itself, the electric conductor of consciousness, the chemical essence of what it means to be alive.